Hi. So if you're joining us now, you're probably studying moon phases. And you might have already done a couple of other models, or maybe you've watched some other videos that we have on moon phases. Remember, we're working with a model, and models can't show us everything that happens in life. You know, bringing the moon into the classroom, not really a practical thing. Waiting for 30 days to see everything, not really practical. So the model we're going to use today is going to help us to recognize why moon phases happen. You know inner planet Janet, so pretend like she's out here in space looking down on the Earth and the moon from above. The other thing we've got to work with is the fact that I want to show what happens over the course of an entire month, not just one moon phase at a time. So Earth does not have multiple moons. This is a time-lapse photography, and we're going to deal with all the moons that happen over the course of the month. We're going to put them all in one drawing. So those are the limitations of the model we're working with today. As long as you understand that, we're going to go forward now. All right, so the first thing we have to understand with moon phases is we need a moon. And so each of these circles here around the big circle represent the moon. Now, notice they go around the Earth, which is positioned in the center. So what do we call a pathway that goes around a planet? Orbit, that's right. So this is the lunar orbit, or the moon orbit, as it goes around the Earth, as it revolves around the Earth. Not rotates, revolves around the Earth. See, I had to stop and think about that one. Okay? So moon orbit, and the Earth is in the center of that orbit. The other thing we need in order to make moon phases is we need light. And that light for us comes from, you got it, our sun. No, that's not a good color. Let's try this. So we have sunlight over here, okay? And the sun is located a great distance away from the Earth and the moon. But our paper is only so big. So we're going to say that the sun is positioned somewhere way over there, but its light reaches the Earth from that direction, okay? So this entire side of your paper here is going to represent the sunlight coming at us, all right? I know, a little hard to see, but that's sunlight coming at the Earth, okay? And we know that the moon is a sphere. Sphere means that it's circular, you know, like a ball. We've talked about spheres before in maybe geometry or in math class. And you've probably played with spheres in gym class as well. So it's a sphere, and it means that light cannot hit both sides at the same time because it's round. The light hits the side that's facing the light, but the side facing away from the light is not bright. So in this case, we want to make sure we have that and we realize it. And if you've done the tennis ball moon, you know exactly what I'm talking about. So we've got the sunlight coming in from this side, and it's going to hit the spheres with the light on the side coming from, and the other side is going to be in the darkness or the shadow. So let's start with the Earth, okay? And on the Earth, the side facing the light, what do we call the side when our side of the Earth is facing the light? That's the day side. I think you all know that one, since elementary school, hopefully. And the side facing away from the light, when we are turned away from the sunlight, we call it night. So this is the night side. That should be pretty easy for you. Now, on our drawing today, we're going to let light be represented by the color of the paper. In my case, the color of my board. So what we're going to shade in is the shadow side, or the night side, or the side that's facing away from the light. So in this particular drawing of the Earth, the day side is the side receiving the light, and the night side is going to be the side that's shaded in. Now when you shade it in, you can color it in all the way, but it doesn't have to be super dark because that makes a big mess on your paper. Does that make sense? Day sides facing the sun. And you know what? I'm going to write that nice and bright here so that you could see that this is where the sun is. Day side's facing the sun. The night side is the side facing away from the sun. Now the same thing happens with the moon, because it's also a sphere. It's just we're not there to notice it. So I want you to go to every moon. Now watch carefully before you do this, because it gets a little tricky. Notice this line is divided, day side, night side. I'm going to go to each moon and divide it straight up and down. Oops, a little bit off there. Right down the middle. And I'm not turning my paper, so that I have each one divided in half. All right? Just like our Earth, every side facing the sun is going to stay the color of the paper, and every side facing away from the sun is going to be shaded in because it's in the shadow. It's not receiving light. So let's do that now. So I'm going to color mine in pretty quickly here. I'm sure your teacher is going to give you a little bit of time, but because you're watching me, I don't want you to have to watch me color in all these moons for a long time. So notice I have my shadow side is the side facing away from the sun. My light side, my day side of my moons, is the side facing the sun. Okay? There we go. That wasn't too bad. So if you notice, they all look the same right now. Now we're going to talk about moon phases. This is what's actually happening out in space from your interplanet Janet viewpoint. Every planet, whether it's our moon or our Earth or Jupiter or Pluto, every planet, the side facing the sun is in the light, the side facing away from the sun is in the darkness. Okay? Because they're all spheres. But the viewpoint, the part that makes the moon phases, is what we see from our position here on Earth. So we're going to have to get a little creative with how we do this. So we're going to leave all the day sides and the night sides, but our viewpoint is going to change a little bit. So we're going to start with the one that's facing the sun. And this is going to sound an awful lot like the tennis ball moon, if you remember doing that or if you've seen that video already. So I'm a person standing here on the Earth, and I happen to be looking at this phase of the moon. Okay, remember, it's a time during the month. It's not a particular moon. It's all the same moon. So if I'm looking at this, what am I going to see? The side I'm looking at is in darkness. So let's make a little box here, and we're going to show what this person sees here. Okay? They're only looking at the shadow side. So if that's their moon, it's a little lopsided moon, sorry. They're only going to see the shadow side. And you probably will be able to remember what that phase of the moon is when all we see is all shadow. What do you think? Can't see it. It's starting out. It's brand new. The new moon. Good. All right. So now a time goes by during the month, and this person happens to be looking at the moon, but they're looking at it when it's in this position between the sun and the Earth. And what they're going to see is the side that's facing them. And I'm going to draw a little line here that says that this is the part that faces the person. Okay? Notice that half of it is in the darkness, half of it is in the light, and that's what they're seeing. So if I make a little close-up viewpoint here of what they're seeing, that person is seeing the portion of the moon on the left is in darkness, so they're seeing half and half. The left side is in darkness, and the right side is in the light. Remember, I'm looking like this, and I'm going to tip it up on edge, because that's what they're seeing. Okay? This is where models get a little tricky. We go through the month a little farther, and the person's going to look at this part here. So I'm going to have to erase this word. You know I love erasing on my board. I lost some darkness here. All right, so this person is facing this moon, and they're looking at this. So what did they get to see? Think about what they saw when they were facing this side, what they saw when they were facing that side. Take a guess. Take a nice hypothesis. not a guess. You should have enough evidence to base it on. So they're seeing only the sunlit portion of the moon. And so are we going to color anything in? No. But you want to make sure people understand that I'm looking at the light side of the moon. So I'm going to put the word light there. And what phase is it when I see all light? Full moon. Good. All right. So now comes the acrobatic piece, where I'm going to have to be the person standing on my head. So the person is standing here on the moon. Sorry, they're not standing on the moon. Why would you stand on the moon? They're standing on the earth looking at this phase of the moon. And just like we did over here, remember they're only going to be able to see the side that's facing the earth. So, looking at their viewpoint, they're going to see half of the moon is in darkness, but to them, so this is my left hand, this is my right hand, so to them the left side is in the light. Now, you can turn your paper, I can't turn my board, okay? But the left side is in the light and the right side is in the shadow. So if I go here, the left side is in the light, the right side is in the shadow. All right? So you can do the same thing for each of the other phases. And I'll give you an example here. Okay? Try it on your own, and we'll come back and see how you did.